Now students, will move to the further. Let us start the discussion. So last class we already completed the most important concept, inheritance. We started 6 p.m. If you come to whoops, there is the inheritance. If we come to this place, so inheriting the features of base class into derived class, we use the following syntax: class name 1, class name 2, and class name n. Class name n plus 1 is giving you class name 1, class name 2, class name n. So we are going to get these many number of subpoints, which I already explained in the last class. Okay. So it's a time to see the programming part in the session. So let us go to the further examples I'm going to discuss. So let's start with, even if you go for inheritance also, no problem. This part you can take it. So here, edit plus also you can take it. You can take this part also. Anything you can take it. So first let me go to the edit plus. So you'll get good knowledge by typing your program here. So let us go for first, because when you come to whoops now, when you come to whoops features here, index, if I open it, classes and object is one pair of elements. Abstraction and encapsulation is another pair. Inheritance and polymorphism is another pair. So I'm going to show you. First 1 hour I will talk about the inheritance. Later I will add polymorphism to the inheritance, so that will continue combined together here. So let me talk about this example here. So let's start. Program for demonstrating the need of inheritance. Need of inheritance I am going to take. Take an example. First example, class C1, in that DEF display 1. I am talking without inheritance for a minute. Print of, I am talking about C1 display 1, C1 display 1, C1 display 1. So coming to the point of it, another kind of class I will take it, C2 DEF display 2, DEF display 2 of self. So print of I am writing C2 I am writing C2 display 2 display 2. So next I'm going to take it display 2, C1 display 1, C2 display 2. Like that I will take like this. Main program I am going to take it, main program. So I'm going to create an object of C1 is this one and C2 is here. Now I'll create an object of what? C1. So I'm going to call this display 1 and display 2. What to do? Create an object. O1 is equal to C1 of, O2 is equal to C2 of, O1 dot F1 display 1, O1 dot display 1, O2 dot display 2 you say. O1 dot display 1, O2 dot display 2. So here two classes, two class objects I am creating, two functions I am creating, two functions, because each function is called what? One object only. So let us talk about, this is called what? Non underscore inheritance. Non underscore inheritance PROC example dot py. Non inheritance example dot PROC dot py. Go to this inheritance here, try to say, here I am going to write it. Done. Coming to this command prompt, here I am going to write it CMD. There I will write it, run as administrator. Here I am writing E colon. So KVR Python here, and say here it is 6 p.m. There I will take it. Oops. CD here, inheritance. This is a 1. So I'm going to take up PY, the non-inheritance program. I got C1 dot display, C2 dot display. With this, as a part of main program, How many objects are created? Come on, make it fast. 4. 4. O1, O2, one object. Display 1, display 2. Each function is also called what? One display, one object only. Name of the function also called what? Object only. Name of the function also called object. So we created it, we called also. So done. If I increase one more kind of class, C3, what should I do again? C3, what should I do again? Again, I will create what here? O3. O3 is equal to what? C3. I will create what here? O3 dot display 3 off. So execute it. See students, got the data. Of course, it is called what? C3. C3, this is a display 3. Execute it, got the data. C1 display 1, C2 display 2, C3 display 3. Got the data. So students, you understood this point to here. Understood this discussion. C1 dot display 1, display 2, display 3. We got this data. Understood? Now, here totally, if 3 classes are there, 3 objects I am taking, 3 physical objects of objects are taken, plus 3 times I am calling display 1, display 2, display 3. 3 times memory space is taken for object, 3 times memory space taken is for what? Display 1, display 2, display 3. Because each function is also called one object. Now I want to go for, think about the next reusability called inheritance. So I'm going for writing, take the same stuff. I'm going to take up others here. Let us move to the further. Class C1, try to take out this entire thing. Inheritance PROC1.py, example.py, 1.py. There I'm writing class C2 of what? C1. Just say pass. What will happen because of that? The method of C1 is coming to where? C2. How it is available in C2? I already said in my classroom. Here, all the features of class name 1, class name 2, class name n are inherited into class name 1. They are available virtually. I said, in Cn plus 1. And we can access them with all the accessing principles of hoops. Students, I already said, C1 things are coming to C2. They are available as usual like other things. Virtually they are available coming to main program. I'm going to take it main program. So coming to the point of it, I will create O2 is equal to what? C2 off. O2 is equal to C2 off. What I'm doing now? O2 dot, what I'm talking? Display 1. How the flow is? Display 1 called with respect to O2. O2 is an object of C2. Control goes to C2. Looking for what? Display 1. There or not there? There. Virtually it is there. Virtually it is available. It is not available physically. As far as this application is concerned, it is taking O2 memory space only, but it is not taking display 1 memory space because it is available virtually. Try to execute this logic. Here I am going to take up. Writing like this. Save. Go to the location now. Py, saying like this. Got the data. C1 display 1, we got it. Let me write it. This point. Leave that. DEF display 2 I am taking. Self I am writing. Print of what I am saying. C2 display 2. This is my function I am writing. How many functions are there here? Coming to the point of it. C2 of what? C1. This method is coming. Along with that, I am taking my own method called what? C2. So in C2, how many functions are there? two. One virtual function is there, one physical function is there. O2 dot display one, O2 dot display two also I am writing. So both of them are calling with respect to what? Sheet O2 only. Earlier I was called what? Three objects are created, but here I am creating how many objects? One object, two functions I am calling. So definitely I am saving one object memory space. So execute that, execute this. See students, py, dear students, observe it. C1 display, C2 display. Go to one more class I will take it. Class C3 of C2, C2, D of display 3 of self. Where I'm writing print of, writing like this, C3 of display 3, display 3. Which object I will create? Which object I will create? Bottommost class object I will create. O3 is equal to C3 of, O3 is equal to C3 of O3 dot display 1, display 1. C1 features are coming to C2, C2 features are coming to C3. So C3 contains in display 2, C1 containing display 1. That also will come to display 3. So total things are there here. O3 dot display 2 and O3 dot display 3. Are you following? So with a single object, I am calling all the three methods. Execute it. See the answer now. It is a multi-level. Mahesh Bhattu. Good. Good student. So it is called a multi-level inheritance. Right, students? Are able to follow? What is the previous example? Three objects created, three memory spaces created. Total is 6. But here how many? One object with all the methods I am calling. So compared to non-inheritance, inheritance is better. Compared to inheritance, polymorphism is the best. Functions, we are having separate classes. We are calling separate objects. We are calling. Which is the best of it? Inheritance. If I introduce adding polymorphism to inheritance, polymorphism is the best. Are you following me? So let us start. O3 is equal to C3 of O3 dot display 1, O3 dot display 2. Online students, try to follow. This is called, what is followed here? Inheritance is followed. Which level of inheritance this is? Multi-level. Multi-level. If you want to go for another part of it, if you want to go for it, see students, only inheritance will not come. Polymorphism will be coming. That is, more meaning will come. That's why I will add polymorphism also to the inheritance. So for your clarity purpose, I am going to write separately. I introduce like this. Class C1, C1 and C2 are the separate classes. C3, what I am doing? C1 comma C2. What type of inheritance? Multiple. Multiple. Diagram is what? C1. This is called what? C2. And this is, both of them are coming to where? C3. C3 it is coming. C1, C2, both of them are coming into where? C3. C3 is coming. What type of inheritance it is? Multiple. So I'm going to get it as same to same. Nothing, only skeleton changes I did. Execute it. Multiple now. Go to the place. Here I'm going to take up. Save it. Go to the place. My dear students, follow me. 2.py. Got this data. So C1 display 1, C2 display 2, C3 display 3. Got it or not? Yes, done. Dear students, C1 of, C2 of. Which inheritance I followed? Multiple inheritance is followed. Which inheritance? Multiple inheritance. Now students, this part we are doing up. This is only method side took it. Let me go to the data members also now. Data members also I am going to take up. Easy, not a difficult. Look into that. Now I'm taking data members. Take two classes. Take two classes. Class C1. I'm going to write it. D of get A of self. There I am writing self dot A is equal to 10. Self dot A is equal to 10. C2. Here I am having get B students. Self. Self I am taking. Self. I am taking self. There I am writing self dot B is equal to 20. 20. Self dot B is equal to 20. Self dot B is equal to 20. Now I am going to take up one more thing. Directly I will take it. Here I am writing class C3. Class C3. In that DEF operation I want to do it. Some operation I want to do it, students. Which operation I need? Get B value I want plus get A value I want. Get A value I want, get B value I want in this place. So what should I do? Say pass. Coming to what? These are all separate classes. To get this get A, to get this get B, I need to write one main program. I will write it. Easy. O3 is equal to C3 of O3 dot operation. I am going to write it, which will give you no answer. Which will give you no answer. I am writing pass here. I am writing O3 dot operation here and pass here. There I will write it. What should I do? Let us access get A error, get B error. Get A, get B error. First of all, again I will write it. RS is equal to self dot A error. Self dot B error. Self dot A, self dot B are present into C1. Self dot B, self dot A present in where? That place. Still you want remove this also. Teesadam idu kuda. I'll remove. Again you will get doubt. Print of what? O3 dot underscore dict. Underscore off. Underscore off. There I written it like this. You execute it. Say inheritance example 3.py. 3.py. Inheritance example 3.py. So here, go to this place, try to run this example, py, inheritance example 3.py, empty. No data present in that. There is no data present in that. How do I add the data now? I want to add the data to this 303. How do I add the data? To add the data, what I should do? Get this A. To get the A, you need to call this function or not? To call that. How do you call that now? So coming to the point of it, O3 dot get A error. Get A function called with respect to O3. O3 is an object of C3, goes to C3, looking for get A. Looking for get A. Get A. Do you have get A here? No, error. Which error? Attribute error. Attribute error, not name error. Attribute error. So see that attribute error. C3 object has no attribute called get A. So get A is not there. Go to that. What should I do now? I should say that C1, comma what? C2. I can say get A. And I should say what again here? O3 dot what? Get B. Now no problem. Now I will say once you call it, automatically that values are available in O3. Execute it. Got the data. Earlier empty. Now I got it. 1020 is available. This is one way. Now you can call it as what? Operation. O3 dot what? Operation. You call it as operation. What is happening? It go to the operation. What is this O3? Operation function called with respect to O3. O3 is an object of C3. PVM control goes to O3, C3 class. Looking for O3 address kept into self. Operation function is calling. There I am writing. Come on. Self dot C is equal to self dot A plus what? Self dot B. Self is containing what, students? O3. O3 address is there in where? Self. Self dot A, self dot B, self dot C. I'll print here. I'll print. Actually, inheritance is a dead easy. Classes are first of all easy only. See this now. Is C contains 30 or not? So ultimately, if I want to print my data, what should I print it? Overall together you remove. Overall together you remove. Print this data now. How do you print this data? In this place I will print. What is this now? Sum of first value comma second value is equal to, like this you try to write it. Dot format of what? Self dot A, self dot B, comma self dot C, self dot C. You execute it. So here sum of 10 comma 20 is equal to 30. Sum of 10 comma 20 is equal to 30. So I think you are understanding about my discussion. Clear or not clear? Yes. So this is about the topic name of how to get the data members here. This is one thing. Let me write one more kind of thing here, students. I'll write others here, and Python I'm writing. Observe it. You are calling like that. Simply you are calling what? Operation here. Are you following? Then when you call just the operation, self.a will be there or not there? Quickly. O3 is equal to C3. What is the value of O3? What is the value of O3? Mudubabulu. So it is totally you are blind. O3 dot what? Underscore underscore dict. It is containing empty. It is containing empty. It is already shown you. Again, I need to show. See how much stuff, how much struggling you are not remembering. 4.py. 4.py. If you bounce with my subject, it is very good. You are all bulldozer, almost 300 kilos weight. Lifting that person is very difficult. So here it is going to be empty. Empty. So I'm calling this as what here, operation. O3 dot operation. O3 does not contain anything. It is going to be containing operation. O3 does not contain anything. Self dot A, self dot B, you will get what? Attribute error. Attribute error will come. Attribute error. Dot A not there. What should I do now? I should say before that, already what functions are inherited into this C3? Get A, get B. Try to call them self dot A, self dot get A, self dot what? Get B you say. Get B you say. Self dot get A, self dot get B, self dot A plus self dot B, self dot A plus self dot B. Both of them are coming to the self dot C, and the data is getting printed like this. Now the answer will be coming now. Execute it, see the answer now. Got the answer. 3.py also getting the answer. I can do either of the manner I can use it. I think you are following me. This is related to what? This is related to what? A simple example on what? Inheritance. But wherever inheritance is there, definitely what will be there? Polymorphism is involving. Are you following me? So let me introduce polymorphism to the inheritance. Then I'll do the example today and tomorrow continuously. Okay now? Shall I add polymorphism to it? So because of polymorphism, what special advantage is coming, I will tell you. So tell me, with inheritance, with non-inheritance, what I am doing? For every class, one object I am creating, I am calling their methods separately. 3 classes are there, 3 methods are there. How many objects? 6. 3 classes are there, 3 objects are there. How many objects? 4. 4. Out of many classes, 1 object only. Out of many methods, all the methods I have to call. Understand? So normal. If 10 classes are there, non-inheritance, 10 objects, 10 functions, 20 totally. If it is inheritance, 1 object to 10 functions, 11. That is 20 plus this is 11. With the polymorphism with inheritance, now only 2. Again, 100 classes, 100 functions. Non-inheritance, 200. With inheritance, 101. With the polymorphism, only 2. Definitely it is a great. Definitely it is a great. So I'll go for preferring what? Polymorphism only. Shall I slowly introduce polymorphism now? So irrespective of number of object, I will take only two statements, I'll write it. So online students, did you understand my points? Can I move to the further? So now I'm entering into the further now. Further examples I'm going to. Polymorphism concept I want to add to your existing examples. To your existing examples, I want to go for this kind of discussion. Very, very easy. Now today, I will add to that polymorphism I will add. Polymorphism I will add. So here, polymorphism I'm going to add. So let us add polymorphism. So in your colleges, when you completed CSC background, your students likes this very much. Students like this polymorphism very much. What your faculties used to teach? Hmm? So Rajneet, sir, I still did not understand. Okay. So Rajneet, my dear student, please come to Hyderabad once. So every topic you are saying you did not understand only. From database onwards, I am seeing. Okay. Now coming to the point of it. Polymorphism, I am going to enter into this place. So generally, when you are entering into polymorphism, the special advantage of polymorphism is having completely least memory space it will take. I already quoted an example, non-inheritance example, non-inheritance example, inheritance example, and then polymorphism example. Polymorphism example. Polymorphism automatically uses which concept? Inheritance will be coming. When I am using polymorphism means definitely it is involving what? Inheritance. So this is only inheritance. This is only inheritance. Here I am having 10 classes. 10 classes. Each class contains one function. So 10 objects and 10 functions. It is totally 20. 20 functions, 20 objects will be there. If it is inheritance, same situation. One object, 10 functions, totally 11. When you come to polymorphism, one object, one function only I will take it. Totally 2 only. You increase to 1000, 2 only. 3000, 1 lakh, 1 crore, only 2. How is that best property? I'm going to introduce. Take olden days. Olden days I'm talking. So when we were the students, this is olden days I'm taking nowadays. Two things I will take up. Two things I will take it. Nowadays I'm taking like this. So let us start with olden days. Suppose I want to buy, I want calculator. I want a calculator. What you will do? I want a calculator. What you will do? Buy what? Buy what? Calculator. Buy calculator. Correct or not? Buy calculator. Calculator is called what? Object. Buy calculator with rupees, some x, with x. So that will take what it will take? P memory space it will take. P memory space it will take plus rupees x is taking. That is the system. I want to buy one torchlight. I want to buy one torchlight. Torchlight I want. Torchlight I want. What I will do? Buy what? Torchlight. That is also going to be called as one object with a rupees called what? With a rupees called y. With a rupees called y. With a rupees called y. So with a rupees called y. So that will take the memory space as what? Q memory space will be taken. Q memory space will be taken. And the rupees plus rupees called what? Y. Rupees y. Next I want to buy. I want to buy one watch also want to buy. Watch. So what is this now? Buy watch again. Buy watch again with a rupees called Z, with a rupees Z, so that it will take some M memory space, it will take M memory space, it will take plus rupees Z is taking, Z is taking. Like that, you take it. So what is requiring this entire thing? For anything is concerned, what you are taking, separate object you are taking, separate object is taking, which is taking what? Separate memory space is taken, separate memory space is taken, and plus some investment on that you are doing it. Is it not taking more memory space? This is called non-polymorphic approach. Non-polymorphism approach. Non-polymorphism approach. Because some of the people will tell poly plus morphism is equal to polymorphism. Like a Telugu grammar, they will tell in school days. Poly plus morphism, polymorphism. They are all cock and bullock story. And what is polymorphism? Somebody will say poly is a poly is a many, morphism is one. It is something like many forms, they will say. That are all called their talent, and great talent those people will have. Let us, what we need to understand, I'm trying to tell you here. This is a olden days, taking more space, taking more amount of rupees. Nowadays, what is happening now? I'm going to give you here. Nowadays, what I'm going to take up. So coming to the point of it, what we are looking into today, you take it, instead of buying these many, you are buying what? Mobile you are buying. Mobile you are buying. That is called what object? Single object you are buying. With a single object, what are you doing? What are you doing? Calculator you are getting. Functionality of calculator you are getting. You are getting torchlight. Plus you are getting what? Watch also you are getting. You are getting many more facilities you are getting it. You want to buy landline also. Landline. In olden days, landline is there. That mobile calling is also coming. So what is this is called? Single object contains what? Multiple behaviors are doing. So one object, how many operations I am doing? Definitely to store my mobile in my bag, it takes least space only. But your calculator, torchlight, watch, it will take more space or not. So which is a better? Which is a better? One object, many operations is better. One object, many operations is better. One more final example. So what is polymorphism? I am going to. This is called which approach now? Polymorphism approach is this one. This is called polymorphism approach, students. Polymorphism approach I am talking about. Single object contains what? Calculator plus what? Torchlight plus watch. Now I am going to talk about another one I am going to talk here. Polymorphism approach. I think you are following me. Another way, follow me carefully. Suppose you take, suppose you are there, you are there, you are there. Your name is called X. X. What is X is called? Object. So when you go to movie, when you come to class, first, when you come to class, who are you that time? You are a student. X is one only. This X is one only. When they sit in the class, X is sitting in the class, is called what? Student. X is going to shop. X is going to shop. Who is that? Customer. He is a customer. X is going to wear movie. He is called what? He is an audience. He is an audience. X is going to wear stadium. X is going to stadium. Is going to stadium. Who is that? X is called a player. He is a player. X is going to something else, some place. He is going to be. X is going to some battlefield. Battlefield. He is going to be called what? Soldier. Soldier he is a soldier. So what it is understanding this concept? What this is comes under? X. X is one only, but it is having how many? Multiple operations are there, multiple behaviors are there. What is that definition I'm saying? A process of representing one, that is called one. That means you are one only. The process of representing one form in what forms? Multiple forms is called what? Polymorphism. The process of representing one form in multiple forms is called polymorphism. Example, another example, you take another example, last and final. Suppose you take, I have some pen with me, some pen is there. One more example I am talking, careful. So I'm having a pen, printing in which color? Which color? Pen. I'm having a pen, one pen I'm having, red. One more color, one more I am using. Which color it is? Green. One more I am using. Which color? Blue. One more I am using. Which color it is? Purple. Like that I am using different colors I am using. Different colors I am using. Different colors I am using. How many pens I am having? One pen. I am not buying red pen. I am not buying red pen. I am not buying green pen. I am not buying blue pen. I am not buying the another pen like this. If you keep all these pens in your packet is completely heavy weight. So in olden days, there is one pen is coming which contains all the refills or not. This is always better. One in many forms. That is called what? Polymorphism approach. We should not tell these examples. So what is the use of, what is the advantage of polymorphism? Polymorphism based applications always gives least memory space will be coming. Less memory space if you want to go for it, you will go for what? So polymorphism definition is what? What is the definition of polymorphism? One form in multiple forms. One form in multiple forms is called what? Polymorphism. I will explain to you what is one form. I will tell what are multiple forms also I will tell you. What is one form I will tell you. What is multiple forms I will tell you. What is multiple forms I will tell you. What are multiple forms I will tell you. One form and one more is called what? Multiple forms. What is one form? What is multiple forms? I will tell you. What is the meaning of one form? What is the meaning of multiple forms? I will tell you. And also tell you what is the form also I will tell you. So this advantage of polymorphism is advantage of polymorphism. You have seen that always takes what memory space? Least memory space. Always takes less memory space will be taken. Inheritance also will take less memory space. Compared to inheritance, still it will take what? Less memory space. So coming to the point of it, now I am going to take up one more thing. Sir, how to? This polymorphism is not a concept of Python, not a concept of Java or something. It is one of the best feature of what? Oops. It is one of the best feature of oops. Best feature of oops only. Best feature of oops. This best feature of oops, I want to go for it. Advantage of polymorphism, less memory space is coming. Best feature of oops. The polymorphism principle, I'm going to write it. The polymorphism principle implemented in where? Python. Implemented in Python by using two concepts. I'm not talking Java. I'm talking purely in Python. Polymorphism is the best principle that you are implementing. Implementing means what? Bring into action. For example, wake up at morning 5 o'clock and opening Python notes is called what? Best feature, best discipline. If you implement, obviously you will get the advantages. If you don't implement, automatically you will lose the advantages. So what is an advantage of polymorphism? Less memory space. So definitely every object-oriented programming will implement that principle. Implemented in Python by using two concepts. What are those? Number one, by using method overriding method overriding. Second one is called what? By using constructor overriding. Constructor overriding. Constructor overriding. Method overriding and constructor overriding. Shahid. So Python always go for what? One polymorphism only, like static polymorphism, dynamic polymorphism. Two things are there in C++, in Java language. I'm not talking about Java. If I go to Java, I used to explain something different. Definition is same only, but implementation will be different. I'm not going to touch it at all into the border points of Java at all. I'm just talking about the points of what? Only Python. By using method overriding, by using constructor overriding. Are you following? What is method overriding? What is constructor overriding? I'm going to talk about it. So I'm going to enter into the, this you remove it. Definition anyhow you understood. Process of representing one form in multiple forms is called what? Polymorphism. What is the meaning of one form? What is the meaning of multiple forms? You will understand. Now I'm talking about method overriding here. Simple. Method overriding is equal to method heading is same. Method heading is same. Head will be same. Plus method body is different. Method body is different. Method body is different. Method heading is same plus method body is different. I think you are following. Method heading is same, method body is different. How it is going to be taken up? I'll give you one example. So when I am using method overriding in my program, we are indirectly implementing which one? Polymorphism. So polymorphism implementing is nothing but applying the method overriding. Let us go to the example. Carefully try to follow. I am going to take it one Python. Look at now. I am taking here non-polymorphism example. Non-polymorphism. And inheritance, but non-polymorphism. Inheritance only, but non-polymorphism. Non-polymorphism example 1.py. That is nothing but what? Inheritance program. Inheritance program I am taking. What is that? Class circle. Careful. Here I am having DEF draw. DRAW. Draw one. Draw one of self. There I am writing a simple example. Drawing circle. Drawing circle. Drawing circle. There I am going to write it. Draw circle. There I am writing another property. Drawing what here? I am writing here. Rectangle I am writing. Draw 2. Drawing what here? Rectangle I am writing. So how many classes I am having? 2. Main program I am writing. Main program I am writing. There I am writing. C is equal to what I am saying? Circle. Circle. R is equal to what I should do? Rectangle. C dot what? Draw 1. Next what I will do? R dot what? Draw 1. Draw 2. Draw 2. C dot draw 1. R dot draw 2. Execute this now. Save this now. Coming to this place. Here you come. In this place. I'll cover this now. Along with that, let me create one small folder also here. Polymorphism. So go to this place. Polymorphism here. There I will add. So here I am writing. Here I am writing. Done. Coming to this area. Py. Here I am having. So what I got it? Okay. CD. Polymorphism here. Execute it. Py. Got the answer now. So what is this now? Drawing circle and a drawing rectangle. That is done. Now students, carefully try to follow. Class circle, rectangle, draw. This is 4 object. This is called what? Non-inheritance also. Today I am writing what here? Circle of. What will happen? This draw one, as it is coming to where? Rectangle. So what I will do? That time I need not write what class? Circle class object I need not to create. I'll create only which object? Rectangle object only I will create. Automatically draw one is coming plus a draw two is also coming. I will call it. What is this now? R dot draw one, R dot draw two. So execute this now. Execute this code. Save this now. See students, got the same answer. Where is the good performance is there? Earlier 4 objects, now it is only 3. Definitely inheritance is having some good other than the non-inheritance. Now same program I'll copy. See students, I am rewriting with a polymorphism concept. There is no tension at all. Happily you try to see. So this is the one I am taking. Polymorphism example dot py. What is the polymorphism example? Say polymorphism meaning one in many forms. Suppose I have this mic with me, microphone is there. I can use for lecturing the subject. I can use the same phone for same microphone for what? Singing a song. I can use this same mic for talking spiritual activity. I can use the same microphone for talking political speech also. So one phone is used for multiple things. Different phones we are not buying it. So obviously draw one of self drawing circle. Next I am going to take up, careful, this is a draw. I am writing, generally people will feel overriding means what I said. Heading is same, as I mentioned already. Heading is same, plus body is different, we said. Now here I am trying to take up, carefully try to follow. Another concept is there. Here you try to follow. DEF, I'm just roughly writing. Draw I am writing. Of self I am writing. Here you are writing. In the same class I am writing. Drawing what you know? Drawing rectangle you are saying. In the same class you have written same function name twice. Heading is same, bodies are different. This is not comes under overriding, my dear students. This is not overriding. Why? C is equal to what I am doing? Circle of C dot what I am doing? Draw, execute it, polymorphism example dot py, polymorphism example dot py. Go to this place. Here I am going to write it. So here I am going to write it, execute it. Which one is coming? Latest one only will be executed. That part you already know. That part you already aware of it. So not this one, py, polymorphism example one, latest one only executing. If you write this one, if you write this part here, like this, if you write it, execute this, this is going to be like this, drawing circle. Latest one only is going to be done. Latest one only will be done. C is equal to circle of C dot draw. Latest one only will be called. Are you able to follow this? So finally, I'm going to conclude my sentences. This is not comes under overriding. If this is coming, how can I call this one? Are you following this? If that both of them are there, both the answers I want. So it is not overriding related to the same class. What should I do then? That time I need to say somebody defined something. I am defining by myself. What is the next class? Rect of what? Circle. Say pause. What is coming in my rect class? Draw method is coming as it is. What I am doing main program? What I am doing in the main program? R is equal to rect of R dot what I am saying? Draw. R dot draw. Draw method called with respect to R. R is an object of rect. Go to rect of what? Looking for a draw. Same draw method was available inside the rect. But which object I created? Rect object is created. Being a rect object, I got which answer? Circle. But I want which answer? Drawing rectangle I want. What I am doing now? Whatever the method is inheriting into the class rectangle, I am going to take the same method heading as it is. I will change the body. Print of what I am writing? Drawing rectangle. This method is called overridden method, we can call. Overridden method. This method is called original method, we can call. Original method we can call. Original method we can call. I think you are following me. This is called original method. You are inheriting into rect class whose heading is same taken and a drawing rectangle. Overridden method is done. How the flow will be? Create an object of rect r dot draw. Draw method called with respect to r. R is an object of rect class. Go to rect class. Looking for a draw, which is a overridden method. Drawing rectangle is printed. Execute this now. See students, what is the answer coming? Drawing rectangle is coming. Tell me, how do you call this method now? I want to call which method? Original method. I don't create an object of what? Circle. From draw method only, I need to call. Earlier when you look at this place, how you called earlier? Self dot A, self dot B. Calling the base class methods or not? But how you can call here? There you go for r dot draw. The draw method, overridden method of rect class. Want to call which method? Original method. How do you call? Self dot draw. When you call self dot draw, what will happen? Same draw method will be called again and again, again and again, again and again. Like you are calling self dot A, base class method, unique methods you are calling. But here you are doing what? Like the old fashion, you are drawing self dot draw. Same method is calling again and again. See the answer now. See the answer now. Same method is calling again and again. Recursively calling the same thing again and again. That will be taking what? Problem. No answer is coming. So, in the method overriding, in the polymorphism, we should not do that. How you can call? To call the original method of superclass from subclass, I will write what? Super of. Super of. Super of. Dot draw, you will write it. Super of dot draw. Draw method called with respect to what? Super of. Who is a superclass for rectangle? It will go to circle class and then this will execute. See the answer now. See the answer now. Execute this program first of all. Answer is coming, both of them is coming. So this is a compulsory question. How many draw functions are there in my class? How many draw functions? Two. Two draw functions are there. Two na one na? One only. How two is available? One only. But how many answers are coming? Two answers. What is this concept is called? One method giving multiple answers. One in multiple forms. One only, but giving how many answers? Multiple answers. One only. We can give for what? Multiple answers. Are you following me? Yes. So I'll go to this. What is superclass? What is superclass, sir? If this is doubt means very danger. What is superclass? Seema. Actually, Seema is a very intelligent student. What is superclass? I'll take it. Here, inheritance, yesterday's class. Notes, notes, inheritance. Here, definition of inheritance. The process of obtaining the data members and methods from one class into another class. The class which is giving data members and methods is called what? Superclass or parent class or base class. Seema. Are you there, Ma? Seema? So Seema. So if you ask this time what is the base class, it's very, very difficult. So super of what? Super of dot draw. Who is the super class for rectangle? Circle. That type of class will be coming. Are you getting up? Next, another one, another example I will carry. Next, one more thing. So take this example. Okay, remove. Next, what I am doing? Class square. Class square I am taking. Square. Square I am taking. What is this now? Rectangle. What I am doing? From rectangle, what is coming? This draw method is coming. What I will do here? Of draw of what? Self. What I am doing? Print of drawing. What is this now? Square. Drawing square. What is this method is called? Overridden method. Overridden method. Which object I have to create here? Square object I have to create. Square object I have to create. S is equal to what? Square of. Very simple. S dot what? Draw. How the flow? Draw method called with respect to S. S is an object of square. Control goes to square. Looking for draw, which is called overridden method. Print of drawing square. Printed. So, see that. Save this now. Polymorphism example 2.py. Polymorphism example 2.py. Done. So here, go to the place. Go to the place. Py. See that. Answer drawing square. Tell me, square draw method. Want to call the draw method of what? Rectangle. How do you call? How do you call? So, Mahesh Bhattu, latest one, what you are answering is a wrong answer. Not a latest one. Here, latest one, oldest one is not there. That is a wrong answer. What you are saying. So, Mahesh Bhattu. So, you have to say what? Super of what? What is that? Draw. Will call super class draw method of square class. Who is the super class for square class? Rectangle. Whose draw method will be executed. That means draw method memory space is created one time only. I got this answer. When you call it, that will come and execute in this place by removing the old answer. When I call from here super dot draw, that will come in the same space, that will execute in the same place only. Like that, I am getting same memory space I am using it. Though I am using three classes, two statements only. Non-inheritance, three objects, three functions. Inheritance, one last object, three functions. But polymorphism, any number of classes, two objects, one object, one function. Execute that. See the answer now. Beautiful. Execute that. 2. I got it square and rectangle. From rectangle, I am going to call it as what? Super of dot what? Drop. Execute. Got circle also. How many draw functions I am having? 3. 1. Giving how many answers? That is called what is coming out from that? What you are smelling it out? One function, one object gives one form, gives multiple answers. Draw is called what? 1. Gives how many answers? This is known as what? Method overriding. Gives you concept of polymorphism. Is it taking least memory space or not? What is the polymorphism definition? I mentioned it. Representing one form in multiple form. What is one form? One form is nothing but what? Original method. Which method? One form is nothing but original method. Original method. I am taking next what? Multiple forms I am going to take it. Multiple forms. Nothing but what? Overridden methods. Overridden methods this is called. Overridden methods. Overridden methods I am going to take it. Overridden methods. This method are called what? Overridden methods. Multiple forms are called what? Overridden method. What is the form? A form is nothing but existence of method. Existence of method. What is the meaning? If the method exists in which class? Base class. It is called what? Original method. What method it is? Original method. If the same method is existing in which class? Derived class. Which class? Derived class it is existing. It is known as which method? Overridden method. I hope you are understanding. Form is nothing but existence of a method. What is the definition of polymorphism? The process of representing one form in multiple forms. One form is nothing but a original method. Multiple forms are nothing but overridden methods. Form is nothing but existence of a method. Base class, original method. Derived class, overridden method. I hope you are following. So, because of this concept, listen. So, because of this, advantage of polymorphism is less memory space. Here, we are getting completely what? Less memory space we are getting. I think you are following me. So, here, circle gives you rectangle. Rectangle gives you what? Square. And there is a draw function. 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 This draw function is calling this one. This draw function is calling this one by saying what? Super dot draw. This is saying what? Super of dot draw. It is saying super of dot draw. It is saying the answer is coming. Now my requirement is I want to call square, want to call what? Circle. The draw method of what? Square. Don't want to call this one. Want to call the draw method of what? Circle. Then super function is not useful. Super function is not useful. That time, what to do? That time, I'll go for what? Concept of class name approach, I will use it. This is by using what? Which one I am using? Super of I am using. Second way, let me show you. Very, very important. Others here, Python. Here I am going to write it. Polymorphism example 3.py. Super of you are using. Here, in place of that super of, there is one more approach is also there, students. What is that? You have to write super of here. Let us take out back. Super of draw. Compulsory you have to come to rectangle, you have to write super dot draw. But I don't want to write that place. I don't want to write this place. I want to write. How do you write it? I will take it. Rect dot, rect dot, rect dot draw. Actually, what is the rect? Class name. What is the draw? Method name. Generally, class dot method name means what is that method type can be? Class level method. But it is what method? That time you need to write a self. New method, new concept. Class name dot instance method name only, but you are writing indirectly what? Self. From there, you can write what? Tell me. Circle dot. Come on. Circle dot. Circle dot. Draw of what? Self. This is by using class name approach. This is a class name approach. Class name approach. This is called class name approach. Class name approach. This also will give you the same answer. This is called 3.p1. Execute it. Here I am writing py operation is same. Understood that? If you want, you can take up this. You can write this, take up this answer. If you want, you can call it as what? Directly. You remove this. I will call directly this one. You can say this one polymorphism example 4.py 4.py execute py got it for drawing square and next is what? Drawing circle. Square is calling and directly going to this place. Drawing circle also you are getting it. But with the super dot draw, it is not possible. Are you following me? Online students, am I clear about that? Quickly. So, Senthil, super of dot draw is not possible. That is not possible. That is a view. You are feeling like that, but it is not possible. One more limitation of super of I will tell you. One more limitation of super of I will tell you. Look at that. One more limitation of super of I will tell you. Others I will take it. Python I am taking. Carefully follow 5.p1. So circle you remove. It's a very really wonderful topic. This is called what now? Original method. I'm talking about polymorphism concept. Are you following me? This is known as what? One in many forms. These programs are what? Polymorphism related. And be careful. Come on. This is a class circle separate, class rectangle separate. Now I'm writing class circle comma what? Rectangle dot pass. Tell me S is equal to square. S dot draw. How many draw functions are coming in square? 2. One is from circle it is coming. One more is from rectangle is coming. So which draw method of PVM gives the preference? Circle related draw na? Rectangle related draw na? Circle related draw na? Rectangle related draw na? Come on. Rectangle related draw. Why? Because it is taking what? Latest one. Correct or not? Like that everybody will feel that is a wrong answer. That is a wrong answer. That will give you whichever is written first in inheritance here, that only will be considered into picture. Generally everybody will think that rectangle, but it will be taken as a first one only. It won't take, it is not a function, it is the inheritance. First whatever the class you have written, that only will be coming. So Python is not defined by you. Python is very peculiar. It is very danger. Py. So what is coming? Drawing circle. Now you change the order. You change the order. Rectangle. You say circle off. What is coming now? Rectangle is coming. Now I will overwrite. I will overwrite. What I am doing now? I will overwrite. So drawing square. This part I will take it. I am overriding here. I am overriding here. Drawing square. What is the answer is coming? Drawing square is only coming. So drawing square is coming. From this drawing square, I want to call rectangle draw method. Circle related draw method I will call. What is the writing here? Super of dot draw. Which super class will be considered? As I said now, rectangle will be considered. So which is an answer is coming? Rectangle related draw will come. See the answer now. Rectangle related draw will come. Suppose if you change the order, comma, what you are writing, rect. What is an answer is coming? Circle is coming. Are you able to follow? Easy or difficult? Dead easy. Go to the place back. Now I'm going to write. How can I call rectangle now? Again, if we write super of dot draw, don't think that it is going to consider what? It is going to consider what? After super dot draw, this super class, second time super class, second class super class. It won't do that. It will give you what? Both drawing circle only will come. Now I'm going to take up what? Super function is not possible to call. The remaining superclass method cannot call. So it is not possible to call. Not possible to call. Draw method of which class? Rect class. Then only one approach is left out. What is that? Rect dot. Draw of self. So we have to use this approach. See the answer now. Got the answer or not? So class name approach. Come on. Super of approach. Madhubabulu. Super of approach. Class name approach. Class name super of approach is immediate super class will call. Which one will not call? Which one will not call? Other super classes in multiple inheritance cannot call. So this will take class name is calling instance method. That's why you need to pass what? Self. In the next class, I'll pass parameters also. Parameters also I'll pass it. Here I'll pass parameters also. Right now, today you understand importance of polymorphism and everything. Did you understand? Similarly, you can apply constructor overriding also you can apply. Constructor overriding also similarly to that you can apply. Are you following me? So first of all, did you understand this concept? So I'll open a small example. Polymorphism, I'll open it. Just to try to understand. What is the polymorphism once again? And see students, if you go to the new example, you taken something like polymorphism example.py. I will take up. Don't think that SAR is executing in this place only. You see that, go to this place, execute it. See that the symbols you see, first of all, the symbols you see. Circle class, you see the symbol, inheritance. This is the method it is related. Inherited into class. This is a method already available. And this see the symbol with red color. This is called what? Overriding the inherited method. Overriding the inherited method. And run this code, same answer like previous. Same answer like previous. So that symbol, by seeing the symbol in the pie chart, don't try to get any tension over there. I think you are following me. Got it up? The symbols are called what? Inheritance related. The symbol up is called what? Overriding symbol. Okay now? So done. Coming to the point back, inheritance only. What is this method? Original method. What is this method? Original method. I was redefined the method of which class? Base class. Into which class? Data class. To do different operations is also called what? Method overriding. So what is the method overriding? Two ways you can say. Heading is same, body different. Another way, redefining original method body in the derived class is called what? Redefining. Why I am redefining? To do different operation. This is one operation. This is another operation. This is doing what? Some other operation with the same method name, same space is using for doing multiple operations. It is known as what? Least memory space is taken because of the polymorphism. So have a look at what is the final conclusion. If I want to use polymorphism, definitely you need to use what? Method overriding, you need to use it. To use method overriding, you must compulsory apply what? Because original method has to inherit into derived class. If you want to use inheritance, I have to use what? Classes and object I need to use compulsory. If you want to hide any method or anything, you can use what? Encapsulation also you can use. So ultimately in real time we'll go for what? Polymorphism uses what? Method overriding or constructor overriding. That is the next class I'll tell you. Which uses what? Inheritance uses what? Ultimately polymorphism uses all the OOPS features. So I'm trying to open one small concept here. Inheritance, polymorphism, I'll just try to open the concept here. So polymorphism in Python, try to read out students slowly. Polymorphism is one of the distinct feature of OOPS. The purpose of polymorphism is that efficient utilization of memory space or less memory space is achieved. Definition of polymorphism. Come on. The process of representing one form in multiple forms is called polymorphism. The polymorphism principle is implemented. Implemented means bring into action by using method overriding feature of all object-oriented programming languages. Even in Java also, method overriding is there. Method overloading is also there in Java. But method overloading is not there in Python. That's why I'm not going to Java side at this point of time. In the definition of polymorphism, one form represents original method. Multiple forms represents what? Overridden methods. A form is nothing but existence of a method. If a method is existing in base class, then it is called original method, one form. And if the method existing in derived classes, then it is called overridden method. That is the multiple forms. In Python programming, polymorphism can be implemented in two ways. They are method overriding, constructor overriding. So method overriding, I want to tell you. Look at the method overriding. Method overriding is equal to method heading is same, method body is different. If it is go for constructor overriding also, constructor heading is same, constructor body is different. The process, another way, the process of redefining original method of base class into various derived classes for performing different operations is called method overriding. To use method overriding in Python program, we must apply inheritance principle. Method overriding used for implementing polymorphism principle. Polymorphism uses method overriding. Method overriding uses inheritance. Inheritance uses classes and objects. Okay. So multiple examples in tomorrow class I will tell you. Constructor overriding also tomorrow class I will tell you. Okay, na? Tomorrow class, don't miss it. So tomorrow class I will go for these parts. Oops will be completing in tomorrow. Constructor overriding, polymorphism started, method overriding, super of you have seen, class name approach also with parameters. So many examples I'll tell you in tomorrow. So all our oops will be completed in tomorrow class. So almost not 11 days, it was almost so many days gone. So don't miss tomorrow class. So it is how many days it is not important. How much knowledge we are getting, that is an important here. So tomorrow don't miss it. It will be completed. And once it is completed, next we'll enter into the another topic in Monday session. So thank you. So we'll stop the class and Monday class, tomorrow class, we'll go for a continuation part of this example only. Right. Thank you. All the best. Online students, if you have any doubt, you can ask me the doubt. I will talk to you. Within few seconds, I will talk to you. Online students, Raju. Raju.
Yes, sir. సార్ ఆల్రెడీ వెన్స్డే సెట్ చేశారు సార్ అన్పిక్లు ఈఎంపీ ఫైల్ మాడ్యూల్ ఇంపోర్ట్ బట్ నాట్ అప్లోడ్ సార్.
అది ఏమీ లేదు, మా చిన్న ఫైల్ అది. నువ్వు అది మళ్ళీ పదే పదే తీసుకుంటున్నావు దాని మీదనే. ఒకసారి చూపిస్తా చూడు, ఫోటో తీసుకో ఒకసారి.
ఓకే సార్.
ట్రై టు టేక్ ద పిక్ ఆఫ్ ఇట్. ఊప్స్ లో నాది ఉండేది.
ఎస్ సార్. ఊప్స్ అండ్
ఎక్కడ, ఏ కాన్సెప్ట్ అది?
క్లాసెస్ అండ్ ఆబ్జెక్ట్స్ సార్.
ఇదా?
ఎస్ సార్.
టేక్ ద పిక్. ఏముంది ఇందులో? ఇది రాయలేవా?
ఓకే సార్, గాట్ ఇట్ సార్.
ఓకే,
థ్యాంక్ యూ సార్.
ఓకే. Tulsi. So, Seema, the real-time applications of Python, if you look at, it always takes the least memory space of any application you take it. Any kind of project when I develop in the real time, any project, not X or Y or something, any project if you take it, to have a least memory space for my application, in Whoops, I'll go for polymorphism. Any kind of application you take, library management you take it, which you implement with Whoops, that will take same function name I will take in many places to do many more operations. So that is going to be called what? Least memory space purpose we use it. So Tunk Pani. So we have a notification on Google Classroom Django with that. So you have to attend that. So you are having full stack Python, you have that now, you have to attend. You have to attend that. Right. Any more doubts? Okay, students, take care. Now I'll go for introducing entering into the that code. I will send that code, the examples and all those things. Take care about it. All the best. Thank you.